So hi, welcome back to my channel. I'm going to give my own summary with the chapter 5, which is Ethernet. So before we start, I'm going to distinguish or going to describe what is an Ethernet is. So Ethernet is a traditional technology for connecting wired. So local area network, enabling device to communicate with each other via protocol and set up rules or common network language. So in addition, Ethernet is the uh, world tradition. It is the traditional from the past, and even though in early generation or in the present generation, it is also used using cables through a local area network. Then the cables also used for communicating with each other by the standard protocols, with the help of standard protocols, and it is called as network language. Then in addition, Ethernet encapsulation. Then from the Internet encapsulation, we have the Ethernet as defined. Ethernet is defined by data link layer and physical layer protocols. So from the data link and the physical layer, from the LLC and the MAC, it is the part of Ethernet. Then Ethernet encapsulation. Ethernet, most widely used as LAN technology, operates in data link layer and the physical layers. Also a family of networking technologies that are defined in IEEE standards, IEEE 802.2 and 802.3 standards. Then Ethernet also supports data bandwidth up to 10, 100, 1000, 10,000, 40,000, and even 100,000 Mbps, or equivalent of 100 gigabytes per second. Then Ethernet standard define layer 2 protocol and layer 1 technology. Then two separate sublayers of the data link layer to operate of the logical link layer, which is control LLC, and the MAC sublayers. Then from the encapsulation, Ethernet encapsulation, uh, as far as I know, it should be network, covered of network layer, and from the data link, it should be LLC sublayer or the MAC sublayer. Then from the physical, it could be the physical layer, and it is the IEEE standard used, IEEE 3 Ethernet, IEEE Fast Ethernet, and the IEEE Giga Ethernet. Then Ethernet to frame fields. Minimum Ethernet frame size is 64 bytes collision frame or RANT. Then the maximum Ethernet frame size is 1518 bytes jumbo or baby giant. So it is completed. So a calculator. Then Ethernet MAC address. Ethernet MAC address is known as the unique addresses in the devices. Then the MAC addresses and the hexadecimal, it is converted. The whole number from decimal is converted into a binary to hexadecimal. Then the MAC address Ethernet identify, you have the layer 2 Ethernet MAC address is a 48-bit binary value expressed as 12 hexadecimal digits, so it is divided into 4. IEEE requires a vendor to follow two simple rules. Then we have the two rules of the IEEE. So first, we have the must use the vendor's assigned OUI as the first 3 bytes. All MAC addresses with the same OUI must be assigned a unique value in the last 3 bytes. So that is what I said recently. The MAC address should be unique. The frame processing complete. Then we have the frame. processing. From the NIC, use information to see if the destination MAC address in the frame matches the device's physical MAC addresses stored in RAM. So if there is no match, the device is discards the frame, or if there is a match, the NIC passes the frame up the iOS layers for the encapsulation process occurs. We have here the address representation, and then unicast MAC address. For example of unicast MAC address is a PC or a desktop connected into a switch. Then the first PC is act as a sender, and its receiver will be 3 PC and one server. This kind of a unicast. Then unicast IP and MAC destination addresses are used by the source to forward a by chat. Then broadcast MAC address. It is different with the first one I said, the unicast. Broadcast address also have one PC, one switch, another 3 PC and two server. Then in addition, broadcast IP and broadcast MAC destination addresses are used by the source to forward a packet almost on the network. Then multicast MAC address. Multicast IP and MAC destination addresses deliver packet or frame to a specific group of number of hosts. It's internet frame. So upon completion of this section, so the next one is the MAC address table. At the MAC address table, we have the source MAC address, we have the port and sources MAC address added. Then in the MAC address, it has a given IP address and given subnet, and also the given destination and the given source. So you need to distinguish if the data will send in a unicast form, on a broadcast form, or in a multicast form. Then if uh, another, we have the frame forwarding methods on a Cisco switch. So we have here the store and forward switch and a cut-through switch. So a stored and forward switch receives the entire frame and computes the CRC. Then a cut-through switch forwards the frame before it is entirely received. So the difference between these two, it is highly different. Store and forward switch and the cut-through. The cut-through switching, so a cut-through or the pass-forward switching, lowest level of latency, immediately forward a packet after reading the destination address. Also typical cut-through method of switching. Then the fragment pre-switching, or what we call the store and forward, or what we call cut-through switches stores the first 64 bytes of the frame before forwarding. Most networks error and collisions occur during the first 64 bytes. So memory buffering on switches. So we have switch port settings, duplex and speed settings. We have full duplex, both ends of the connection can send and receive, and half duplex, only one end of the connection can send it at a time. Uh, Different on the full duplex and the half duplex. Full duplex is a full-fledged, and the half duplex is also in a half. It can only one end can send at a time. So For example, a two PC connected and sending to each other. Only PC1 can send his data to the PC2, and the PC2 will reply only if the data sent by the PC1 is received by PC2. So, an example of the full duplex, even though you are not so, even the two pieces are not, or even the two pieces are not yet recognized, if it's use a full duplex connection, you can send and receive or send vice versa a message at the same time. Then duplex and speed settings. So the common cause of a performance issues on 10 to 100 Mbps Ethernet, like a when port on the link operates a half duplex and the other on full duplex. So it might be in a conflict if the one end of the device is using a full duplex and another side using half duplex. Then the address resolution, we have destination on the same network. There are two primary addresses assigned to device on the internet. You have the physical address, the MAC addresses used to internet NIC, the internet NIC, and the communications on the same network. Then you have the logical address, also it is a IPA address. And introduction to ARP functions, or the ARP table. An ARP table used to find MAC addresses that is mapped to a destination IPv4 address. So as I've said, it is used only it is recommended to use in an IPv4 DR process. Then if the destination IPv4 addresses is on the same network as the source IPv4, the device will search the ARP table for the destination IPv4. So the ARP table will be the responsible of searching the destination address of the sender. Then the ARP request sent when a device needs a MAC addresses associated with an IPv4 address and it does have an entry, it's ARP. So ARP reply. The device with the target IPv4 address and the ARP request will respond with an ARP reply. The ARP reply is encapsulated, so it could be it's not easily to access by others. If you are not the sender, you can't access it because it is secured. Then destination MAC, this is MAC address of the sender. Source MAC address, this is the sender of the ARP. Then type is type of the message, the ARP message. Then removing entries from a ARP cable timer removes ARP entries that have not been used for a specific period of time. And commands may be used to manually remove all or some of the entries in the ARP table. So that's all. Thank you for the chapter or watching me, and hope you understand and learn with the chapter 5 summary. Thank you.